All right, so now that the call is now being recorded, I think it's a good place to kick off. Yes, I was made to understand that no one was able to access the recording from the previous session. Am I correct, Mr. Lawale, or has that been fixed?
No, no, sir. We've not been able to access it.
Okay, so that's because the we have a common link that we use for office hours, which has been scheduled by the operations department of Nibok University, and I sent the link to them to allow access by everyone, but I suppose that didn't happen. So what will happen for this one and maybe that other one is if the link isn't available till the end of this week, say tomorrow at the most, I would have to download it and also upload to my YouTube channel and share the link with everyone so you can have access to it. Is that okay?
Yes, sir. That's better, sir.
All right. Thank you very much. So let me share my screen as we move on with the subject matter of today, starting with rational function. Meanwhile, I'd like to say that the exam questions are already. I was doing a review of it yesterday, and I'm happy with what we have discussed so far during this office hours. I think this must have been very helpful, especially for those of you who had taken time to join the office hour. And if you had paid attention to most of the things that was mentioned, you wouldn't have issues with the exams. And mind you, it's going to be a multiple choice question, which means that you should remember all the possible shortcuts of getting the problem solved because we won't be marking steps, unfortunately. We will only mark the final answer. And although the questions are structured such that you may not require to do a lot of workings, right? So that is why, as I continue, I will try to talk about the longer method of doing the stuff or solving the problem, and as well as the shorter method. So the longer method will help you understand the logic behind it, while the shorter method will help you answer to multiple choice questions in the examination situation. Having said that, let's get started as we begin the discussion of today's topic, which is partial fraction decomposition. I think I have to increase this a little bit. Okay, partial fraction decomposition. Please confirm you can see my screen clearly by giving me reaction.
Yes, sir.
All right. Okay, so when we talk about partial fraction decomposition, what we are actually referring to there is the ability to reduce a rational function. So when I say rational function, a rational function is a function in the form f of x over g of x, where g of x is not equal to the zero polynomial. So a fraction that involves polynomial at the top and polynomial at the bottom is called a rational function. So being able to split this type of functions into smaller units, right, is what rational or partial fraction decomposition is all about. Okay, and there are techniques of solving partial fraction decomposition, which I'll be mentioning on this call. I'll mention the techniques of solving partial fraction decomposition and when to use what techniques. Okay, because there are some criteria you have to look out for to decide on which techniques will be suitable to solving the particular partial fraction. So I'll start with the one that we discussed, which is on polynomials or long division, right? Now, the condition is if, so here are the conditions I want to give, or the single condition I want to give. The condition is if the degree of f of x is greater than or equal to the degree of g of x, right? Then you can resolve into partial fraction by polynomial long division method. Then, of course, partial fraction decomposition can be done by polynomial division. Let me just write it then. Partial fraction decomposition can be done by long division method of polynomials. I'll give you a typical example. So for instance, if you are asked to resolve, so this is an example for this first condition. Example, if the question says resolve into partial fraction decomposition. So when I say PFD, it stands for partial fraction decomposition. And you're given a fraction, you're given a fraction as you're given a fraction as say 2x squared plus 3x, yes, 2x squared plus 3x over x minus 5. Yes, this is an example. 2x squared plus 3x over x minus 5, and you're told to resolve into partial fraction. When you look at this rational function, you notice that the denominator, the degree of the numerator is 2, right? And the degree of the denominator is 1, which means that the degree of the numerator, the fraction at the numerator, is actually greater than the degree of the fraction at the denominator. Therefore, this method can be applied. Long division method of polynomial can be applied to resolve this particular fraction into partial fractions. So let's quickly solve this together. Of course, we've done it yesterday. I mean, we've done it the last time we met by partial fraction, I mean by long division method. And that is why I want to start with this. So when you see a question like this, right, the first thing you have to do is to check. When you see if a partial fraction, or when you see a rational function, you're told to decompose it into partial fractions. The first thing to do is to check if the denominator or the degree of the numerator is greater than the degree of the denominator. If it does, then just think of doing long division method. Let's quickly divide this by long division. We have 2x squared plus 3x divided by x minus 5. Now, as we did last week, you take out the first term from the dividend, that is 2x squared divided by the divisor, x, and this will leave us with 2x. Write 2x at the top and divide the entire divisor by that quotient, 2x. 2x times x will give 2x squared. 2x times minus 5, that gives minus 10x. Subtract, and when we subtract, we have 2x squared minus 2x squared, that is 0. 3x minus 10x, that is 3x plus 10x, which is 13x. If you understand this step, can you give me a reaction? All right, thank you for the reactions. So let's take the next step. The next step is to pick this 13x also divided by x, which is the first term of the divisor. 13x divided by x is 13. That's going to be plus 13 at the top. Multiply 13 through by the entire divisor. Excuse me. Okay, so I can see someone's question. Let me go through again. That is from Zainab. It says, "Sir, why are you solving using long division method?" So I'm solving. This is the condition. This is the condition. For you to know if you are going to do it by long division, you look at this condition here. So once you see a rational function, like I said, a rational function is any function that is written in this in this form, something over a polynomial over another polynomial, that's a rational fraction. If you are told to decompose it, the first thing you do is to inspect the degree of the numerator. Inspect the degree. If it is greater than the degree of the denominator, then the way to resolve it is by long division method of polynomials. Did that answer that? Does that answer your question? Good. That's why I'm doing this. So I will show you other forms that will help you understand it better. Now, if divided plus 13 and multiply 13 by the entire terms, that means 13 times x, that will give us 13x. 13 times minus 5, that's going to be minus this is 15, right? 13 times 5. My mathematics has reduced though. This is 65, minus 65, right? So we subtract these terms again. 13x minus 13x is 0. And it means that we're left with 65. Is that correct? Is my calculation correct? Good. Now, which means that therefore, by the partial fraction decomposition, we have 2x squared plus 3x all over x minus 5. This has been decomposed into the quotient 2x plus 13 plus the remainder 65 over the divisor x minus 5. So this is what is known as partial fraction decomposition. We have decomposed this rational fraction into two fractions. This can also be seen as over 1. So these are two fractions, and that's why it's called partial fraction decomposition, like decomposing the fraction into two fractions. And one might be asking yourself, like, why do we have to do this? Is someone's mic is unmuted? Does the person have a question for me? Or has a question? Okay, let me continue. I guess that must be a mistake. So you might be asking, why do we have to decompose? Like, why on earth can we be told or asked to decompose a fraction into partial fractions? One of the reasons we learn this is because most times in some areas of application, especially also in mathematics, you might be required to actually integrate some functions like this. So sometimes you will see something, you say integrate this function with respect to x. And to integrate this function, you can't integrate it except to decompose it. Now, by the time it's decomposed, you notice that to integrate the right-hand side becomes easier. You can't integrate the left-hand side exactly the way it is presented. But once you decompose it, integrating the right-hand side becomes easier and straightforward. So this is one reason why, there are still several other reasons, but this is one of the reasons why we learn how to decompose fractions into partial fractions. Please, do you understand? Are we together? If you understand, can you give me thumbs up? I'm not seeing our reactions. Thank you, Olawale, for the reaction. Okay. So remember, as you're learning, whatever you're learning in mathematics or any field, it's good you learn it by knowing the why. Okay. Know the why and not just the how always. Is that communicating? Am I communicating?
Yes, sir.
All right. So now I will give you another case where you would have to use maybe another method to decompose your fraction. Now, the case is, what if we have the the numerator whose degree is less? So this is case number one. Case number one, when the degree of the numerator is greater than the degree of the denominator. Case number two, if the degree of f of x is less than or equal to the degree of g of x. Don't forget that we're starting with this f of x and g of x, right? Where we assume that the f of x is the polynomial at the top, the numerator, while g of x is the polynomial at the denominator. Now, if you notice that degree, and that we also notice that the polynomial is actually having a distinct linear factors. What do I mean? If the polynomial can be written as, say, f of x over some distinct factors a or x, let me use x minus a times x minus b. Now, if your polynomial can be written this way, the first thing is that the degree of the numerator is less than the degree of the denominator. Secondly, the denominator can be written as distinct linear factors. So what I mean by distinct linear factors, I mean it can be broken down as x minus a over x minus b. Now, to decompose this type of fraction, it's going to be written as a over the denominator, the first factor, x minus a, plus b over the second factor, x minus b. It could be plus or minus. Let me just use plus as the basic or fundamental. So let's take one example to further explain this particular case number 2. Now, it can be told to resolve into partial fraction, resolve into partial fraction decomposition, or decompose into partial fraction. And you'll be given the polynomial, say 3x plus 5, 3x plus 5, all over, excuse me, all over, let's say x minus 1 and x plus 2. So this is a typical example of the type of situation I just explained. Now, when you look at this polynomial, you would have seen already that the degree of the numerator is less than the degree of the denominator. True or false? Who can see that? Is that or is it obvious that the degree of the numerator is less than the degree of the denominator? Can you obviously see that? If you can obviously see that, give me thumbs up. If you can't see that obviously, I can actually explain why I'm saying that the degree is less. Okay, I can see almost everybody on the call that had given me reaction agrees with what I am saying. They can see it easily. But in case you can't see it easily, right? In case you can't easily see it, when you expand the denominator, this fraction can also be written as 3x plus 5 all over x squared plus 3, no, minus 1, okay, minus 3x, x squared minus 3x minus 2. So this, it can, is it minus 3x? X, this times this, x squared plus 2x, this is minus x. So that's going to be minus x, not minus 3x. Minus x actually. Minus x minus 2. So you can see that this is a linear polynomial with degree 1, and this is a quadratic polynomial with degree 2. Can you see it? You can easily see it now. So sometimes the question can come in this form. You'll be told to decompose this rational function into partial fractions. So to decompose it, it means you would have to factorize denominator to obtain these factors, just like it was given before you can now go further. But the bottom line is why I expanded the denominator is I wanted you to see that the degree of the numerator is indeed less than the degree of the denominator, and we can all see that clearly. Now that we have that condition being satisfied, and we have the condition that this denominator is written as linear factors, distinct linear factors. So we would use the rule that was given above, which says that I can split this particular fraction as a, some numbers, a over the first factor, x minus 1, plus b over the second factor, x plus 2. If you understand that step, give me thumbs up. I'm not seeing reactions.
So I don't understand this.
I don't understand that, sir.
Because the denominator, that's a negative and a positive sign.
Number signs.
Yeah, and the equation is they are both positive.
Oh, okay. So the sign does not really matter. What matters is that you are able to split it like this. Whatever is here will be under A. Whatever expression is here will be under B. That is what matters. So the sign does not matter. Do you understand that, Samuel?
Yes, sir. Yes, sir.
Good. So it doesn't matter. The sign doesn't matter at all. What matters is just know the rule. The rule is that the degree of the numerator is less than the degree of the denominator, number one. Then the other rule is that these two expressions say they are distinct. So what I mean by distinct, it means that there are two different expressions because there is a way, the way to treat this type 2x. I'm giving another example. Just hold on. The way to treat something like this, 2x minus 5 over x plus 2 times x plus 2 is a different way to solve this type of partial fraction decomposition because the factors here are not distinct, they are the same. So you cannot have it as a over x plus 2 plus b over x plus 2. There's a different way to handle this. This cannot be the correct interpretation. So the thing is that what you look out for is the first condition is the degree of the numerator less than the denominator. If yes, ask yourself, are the factors at the denominator, are they distinct? That means, are they different? If yes, then use this rule, use this particular rule. But if the factors are not different, if they are the same, just like this example I gave here, I will show you how to solve that one later. But let's just finish this particular one. Yes, Olawale, hand is up.
Yeah, yes, sir. Sir, please, this number 2, I am totally lost from what you did in number 1.
Okay, let me explain again. For
Thank you,
number
sir.
1, for example 1, it is the case where the degree of the numerator, the degree of the polynomial at the top is greater than the degree of the polynomial at the bottom. You can see here that the degree is 1. And here, I mean, the degree is 2 at the top here, but here the degree is 1, though it's not written, but whenever the degree is not written, just know it is 1. So whenever such happens, please, if you are decomposing into partial fractions, simply perform your long division method of polynomial that we learned last week. Whenever this is the case, just do your division of polynomials, and then
Okay,
you
sir.
obtain a decomposed fractions of the given partial, rational fraction. But if the case is that the degree of the numerator is less than the degree of the denominator, then the method of solving that type of fraction, partial fraction, is different. It's not going to be long division again. Long division will not work. Now, why? Who can tell me, why do you think long division will not work? I mentioned it when we were discussing last week's session. Who knows why the long division will not work?
Is it because of the degree?
Yes,
You won't
beautiful
be able
explained.
to divide.
Exactly. We won't be able to divide. So since we cannot divide, what else can we do? Thank God for mathematics and rules. So we have a rule that says whenever such division cannot be done, there is a particular rule, there's a particular formula you can use. And this is the formula I have just given. This formula I just put in the rectangle. The formula says just pick A. Just pick A. A is a variable. A represents any number. Say A over the first factor plus B over the second factor. But again, there's another condition you have to check. You have to check for before you can use this rule. And the condition is that these two factors are distinct. They are different, like I explained. It is not saying x plus 2 twice or x plus 2 squared. If you have this type of factors, then this rule will no longer work. I will give you a rule to use for such kind of case. Mr. Lawali, do you understand?
Yes, I'm with you, sir.
And I hope we all understand, because the thing is, always know the why, always understand the why. Why am I using this rule? Why am I doing it this way? Because if you want to just memorize and begin to solve, you get to a point where a question will be given and then you just become stuck, but know the why, which is very important. So I believe we all know the why of this particular method now. Case number 2. Do we? All right,
Yes, sir.
thank you.
Me, I do not understand.
Grace. Grace says she does not understand.
I don't even understand anything.
Ah, Konida Fueshu.
Ah,
Okay. Okay. Grace. Grace, did you join it or you joined at the beginning?
I joined late actually. I joined before, but I left the class because of network issues. So I joined back now. Like everything you are doing is just like you're saying you are speaking China. I don't even understand anything at all.
Oh my God. Rose said I'm speaking Chinese. I'm speaking Chinese language. Someone is saying they don't understand too. Okay, that is still from Rosemary. Okay. Okay, sorry. Grace is the person that is speaking, and Rosemary also said that she don't understand anything.
yes, sir.
So how do we go about this? Salawali, what do you suggest?
So I suggest we use the shortest method.
The shortest method?
Yes.
There's no short method. It just depends. That's why I'm saying it depends on the why we are solving.
Yes. So the thing about math is that if you don't know the why, right? When I show you the short method, you will not even know what to do. Like you'll be very confused. Because even in this particular example I'm solving right now, the short method would be to actually solve following the long method, but you're going to skip some steps because you already mastered the concept in your head. Do you get? So you have to know the why, and that is why I'm taking my time to explain. But for the fact that some people do not understand, I think I know why. I think I can predict why they don't understand, or I can assume why they don't understand. It could be maybe because they didn't join the first session, or they are not friends with algebra because of the letter and the numbers that they see around, or some of the terms that I'm mentioning they're not familiar with them because they've not seen the videos in my classroom. To be sincere, Grace,
They
have you
don't
gone
like
through
math.
those lectures on the LMS? To be
They
sincere.
don't like math.
Yes, sir.
You've gone to the questions. Okay, they don't like math. Maybe it's math, maybe.
Sir, we have gone through a lot, but still start to understand.
Wow. Okay, so God help me, give me wisdom to explain this in a very simpler form. Let me try my best to see what I can do. Right? I guess it's because I am using what is it called? I'm using variables. I'm playing with variables, but I don't know how best I can explain this thing without playing with variables.
If
You said
you
it's
if
not
you can give us the exam questions, you'll be very clear with that. So that
okay.
Example question, bravo.
one is not very
I understand.
be serious with that one.
I get you, no problem. All right, let me give you the exam questions. Okay, let's do that. So please pick up your pen and your paper and write down the exam questions as we as we continue. So you better listen to this one very well because from here you will see the exam question for what I'm saying. In fact, everything I've been saying is in the exam actually. Everything I've been saying in the exam. So if you understand what I'm saying, when you see the exam, you just be laughing and say, "Kai, this exam is too simple." All right, so let me just continue the example. Don't worry, I'll take like 2 examples and then just follow the logic. So look at it. We have two different factors, x minus 1 and x plus 2. They are not the same. They don't look alike. Whenever that happens, you write your decomposition like this: a over the first factor plus b over the second factor. Just follow me. I will take on that example. Don't worry. Then when you do that, what is the next step? The next step is that you are going to write what is at the top. This guy at the top. Write it down. 3x plus 5 equals what next? You will write this one here. The a. Write the a. Then use it to multiply what is under b. X plus 2. Then write your plus sign. Then now write the b, use it to multiply what is under a, x minus 1. If you understand this exchange I just did here, can you give me a reaction? All right, perfect. So that is the exchange. So you can see that I didn't pick this one. I didn't pick this one at all. I left it there. I only picked the numerator, which is 3x plus 5, and then I picked a and multiplied it with what is under b, plus I picked b, multiplied it what is under a. So at this point, there are two ways to proceed from here. There are two ways to do it, but I'll just use one way to keep this short and simple so that it doesn't confuse everybody. So what is the first method? What is the way I want to use? The method I want to use is what you have inside the bracket beside a, that is x plus 2, right? Say equate it to 0. Let x plus 2 become 0. Now, if x plus 2 is 0, what is x? This means that x is equal to minus 2. When you make x the subject of the formula, that is, if you bring 2 to the right-hand side, plus 2 at the left comes to the right, it becomes minus 2. Is that correct? Please, is that correct?
Yes, sir.
Perfect. So by the time you do that, what's the next step? Now you substitute. So by substitution, it means whenever I see x plus 2 in this equation, what will I put? I'll put 0 because I have said let that expression be 0. And for the remaining parts, whenever I see x, I'll put minus 2. Now let's do such substitution. So it means this becomes 3 times minus 2 because x is minus 2 plus 5 equal to a times 0 because I've set everything there to be 0 plus b times minus 2 minus 1. If you understand my substitution, can you give me a reaction? Give me thumbs up if you understand my substitution. Good. Now with this substitution, you can simplify further. 3 times minus 2 is what? Minus 6 plus 5 equal to a times 0 is what? 0 plus minus 2 minus 1 is what? That is minus 3. Is that correct? Minus 2 minus 1 is minus 3. So this becomes minus 3b because b times minus 3 is minus 3b. So when you solve further, we have minus 6 plus 5 is minus 1. Minus 1 equal to minus 3b. Dividing both sides by minus 3 over minus 3 over minus 3. This, we cancel this out. Then our b becomes 1 over 3. That's the answer. Very, very straightforward and simple. Correct or wrong?
It's a little bit easier this way, sir.
Yes, it is actually, everything's actually easy. So the thing is that if you are able to find time, I know that most of us are very busy. If you're able to find time to practice, you solve 1, 2, 3 problems. I tell you, believe you me, it will become very easy if you're able to practice. So that's that about that. We have gotten the value of b. That's not all. We have just solved for b. We need to solve for a also. And when we solve for a, we can now substitute and we've gotten our partial fraction decomposition. So let's solve for a. The same thing that I did at this point, the same thing that I did here by picking the expression beside a and setting it to 0. I will do the same thing for the expression beside b. So watch me as I do that. I will say, let the expression beside b is what? X minus 1, right? Let x minus 1 be 0. Now, if x minus 1 is 0, what is going to be the value of 1? The value of x. The value of x is 1. When you bring minus 1 to the right, it becomes plus 1. Again, we will substitute. It means wherever we see x minus 1, in this same expression, wherever we see x minus 1, we put 0. Wherever we see x, we put 1. So that's going to be 3 times 1, because now x is 1, plus 5, equal to a times 1 plus 2. A times 1 plus 2, I'm writing 3 instead of 2. A times 1 plus 2 plus b times 0, because we've set x minus 1 to 0. 3 times 1 is 3. That is 3 plus 5 equal to 3a, because 1 plus 2 is 3, plus 0, because b times 0 is 0. And 3 plus 5 is 8. 8 equal to 3a. Now dividing both sides by 3 again, we have the value of A as 3/8. So now that we've gotten the values of A and B, we can now substitute those values back into this particular fraction. Yes, someone have a question for me?
Is it not 8/3?
Oh, sorry. Thank you very much. That was a mistake. It's actually 8/3, not 3/8. 8/3. All right. So therefore, the partial fraction decomposition becomes 3x plus 5 over x minus 1 times x plus 2. This equals, the value of A is 8/3. 8/3 into bracket x minus 1. The value of B is 1/3. 1/3 into bracket x plus 2. So this is the partial fraction decomposition. What it means is that the expression at the right-hand side is nothing but the same thing as the expression at the left-hand side. When you simplify that expression at the right, your answer the answer you will get will be the same thing as what you have at the left, what you started with, which is this expression at the left. Is that clear?
Yes, sir. Is this one question over 60?
Come again?
Is this one question inside 60 you want to give us?
Yes, by the special grace of God.
That's
because I don't want to stress. I don't want to stress people.
Yeah, just oh my God.
I don't like stressing my students, so I just gave very simple questions like this.
Star, this is stressful. This is enough.
This one is theory now.
I'm serious. It's a very direct question, and you will not even bother stressing yourself.
Sir, area of concentration, sir.
Yes, area of concentration. You have to focus on number system, real numbers. You must know your real numbers. You must know your inequalities. You must know your indices. You must know your laws of logarithms. You must know your logarithms. Yes, laws of logarithms. You must know polynomials, which is what we treated. And this one that we're treating, partial fraction, you must know your partial fraction decomposition. And you must know your functions, how to determine domain and range of functions. You must know expansion, binomial expansion. And you must know your permutation and combination. And a little bit of mathematical induction. So you can see that
scheme of work or the AOC. Is AOC we asked of, not the scheme of work, not the cost AOC.
It's AOC I'm giving now. Zainab, behind is
course outline.
Okay, yes. Good afternoon, sir.
Good afternoon.
So with what you solved there, it simply means that this equation on the left-hand side is equals to the one on the right-hand side. So if we should solve the one on the right-hand side, we will get the same thing as one on the left-hand side.
Exactly.
Can we confirm that?
Yes, we can. Why not? If not, if we have the time, yeah, I would love to do that. Let's quickly confirm that. What is happening to my pen? My pen has disappeared, though. I hope this is not networks. Somebody said I should just pass us. How do I want to pass us? Can you tell me how are they passing people so that I can maybe learn and do that? It's like my network is becoming unbecome. My network. Sorry, my network is. Just give me a minute. Let me quickly restart my network. Okay, 70/100. Okay, is that how to pass? Oh, Rosemary, okay. I will go on. There is one course, actually. I saw the course in Harvard University. They call the course Passiology, like passing students. I think I will, I will go and study the course. But the only problem is that the course is like a 6 years program. So it has to take me like 6 years to understand that course. I'll come and pass you. What did we do, Rosemary? Zainab, do you still have your hand up? Or it was the previous hand? Okay, my screen is up now. Let me quickly attend to Zainab's request. She said, let's solve this right-hand side and see if we get left-hand side. 8/3 times x minus 1 plus 1/3 times x plus 2. The LCM here is 3 times x minus 1 times x plus 2. That's the LCM. Now, 3 times x minus 1 we cancel out. We have 8 into bracket x plus 2 plus, then we pick the other one, which is 3 times x plus 2. We cancel this. We have 1 times x minus 1. And when you expand, open your bracket, this becomes, when you open your bracket, you then have 8 times x, that is 8x plus 8 times 2, 16, plus x minus 1, all over, we have 3 into bracket x minus 1 times x plus 2. Let's simplify further. 8x plus x, that will give us 8x plus x, that is 9x, and then 16 minus 1, that is plus 15, over 3 into bracket x minus 1 times x plus 2. And 3 is common at the top, so 3 can divide 9 and 15. That will give us 3x plus 5 over 3 into bracket x minus 1 times x plus 2. So 3 cancel 3. Then we have our answer 3 plus x, 3x plus 5 into bracket x minus 1 times x plus 2. So you can see, Zainab, that what we have at the end of the day is the same thing as what we have at the left-hand side. And that's why we call it partial fraction decomposition, to decompose a rational fraction into 2 fractions. All right, that's okay, right? So this is the reason why we say math is very simple and it's meant for lazy people, because you can always
Sir,
check.
please don't cancel yet.
Oh my, sorry. Okay, how can I undo my
Stop
action?
again.
No, I will undo my action. Don't worry. I've undone my action. I've undone my action. That's correcting. Since we did not read English, we didn't study English in university. It was math that we studied. Okay. So you want to, I believe you're taking the screenshots, right? So that we can quickly take one more example. I believe by the second example, everybody will get to grasp the concept better. Are we taking your screenshots?
So I will get the video now.
Okay. This is to check. So let's take one more example, please. I need everybody at least. So one thing is this. Let me just clarify some things. In the exam, right? Since it's objective, it's multiple choice. It's not like theory exam. It is in theory exam that you need to solve all these like this, all of these in theory exam. All right. But since this is an objective question, you will not be required to solve all these things. Okay. The best thing that we can ask in a multiple choice is, what will be the value of A when this fraction is decomposed? So it means you can just solve for A or solve for B, and that is all. You don't need to go further. Just give the answer for A. All right. And even if you be given any expression to decompose, okay, it's going to be an expression that can be easily decomposed without so much calculation, because you know that it will take a lot of time to decompose fractions. So just give you something that can be easily decomposed. And maybe I will think of an example. I can say, or they can even give you kind of simplification of rational function. Let me think of an example I can quickly put up here. So let me give you this example. I can say simplify. The question can come in form of simplification. Say it can be simplify something like x squared plus 4 over 2 over x minus 2, something like this. Let me just give you this example, x minus 2. So when you see simplify, I know somebody would think of, okay, since this is polynomial, right? And the numerator is bigger than the denominator. Somebody might want to go and start solving using this method I have explained here. Which is it wrong? No, it's not wrong. When you solve it using this method, you still get the answer. But this is going to be a longer method. So how can you handle this type of question when you see it in exam? Simply think of, okay, sorry, this one has to be minus, not plus. So when you see a question like this, simply think of what is known as difference of two squares. So x squared minus 4 can be written as x minus 2 times x plus 2 divided by x minus 2. And your answer is what? X plus 2. That's your answer. Shikenan. That is your answer. Straightforward. Can you see what I'm talking about? But imagine you want to solve this thing using long division. I will solve the same thing, the same question using long division, and you see we arrive at the same answer. But long division will take longer time. Watch. If I have x squared minus 4 divided by x minus 2, bring out x squared divided by x cancel 1, I have x, multiply through x squared minus 2x, subtract. This is 0. You have 2x minus 4. Bring out 2x again, divided by x cancel x, that is plus 2, multiply through, that is 2x minus 4, subtract, that is 0, 0. So what is the answer? X plus 2, which is the same thing as this. What is shorter? This method. But will you be able to solve it using this method? If you don't know difference of two squares, no, you won't. So it's what I'm talking about. So the questions that will be given will be questions that will require you to apply some short method and obtain your answer. But if you do not know those simple tricks, you will waste a lot of time trying to solve one question. I don't know if I'm making sense at all.
You are, sir.
Yeah, so sorry, in a situation whereby we now get this 4 now is an odd number. So what do we do?
So now note that in setting of examination questions, especially when it's multiple choice, the examiner is also very, very sensitive in type of questions that they are solving, or they are setting rather, because we know it's multiple choice. So if it was theory, I can give you a question that you have to solve plenty steps, because in theory, we are not marking your final answer, we're marking the method and your steps. So which means that you may actually get the final answer wrong, but you still pass that exam. So a question can be 5 marks. Now, out of 5 marks, it is only half that will be given to the final answer. So the other steps, you must have gotten maybe 3 steps, 3 over 5. Even if you fail your final answer, you get 3 over 5 for that question. So I can solve complex, I can set complex questions. But for multiple choice, we will set some simple but technical questions. Like this type of question is very simple, but it's technical in the sense that if you do not know the difference of two squares, you want to solve it using long division method. And that will take you more time, and you know you have less time. So one thing about these types of questions, based on the question you asked somewhere, is you have to know what is called difference of two squares. So what do you mean by difference of two squares? Difference of two squares. It means whenever you see any expression that can be written as a squared minus b squared, any expression that can be written in this form can be expressed as difference of two squares, a minus b times a plus b. This is difference of two squares. You can always express it like as this, any expression, be it odd number or even number, given that it can be written as a number raised to power 2 minus another number raised to power 2. I'll give you several examples of difference of two squares. And please take note. Take note of what I'm saying here. It will help in your exam. Now, if I have something like this, 4x squared minus 9, please, is this difference of two squares? If yes, how can I express it? Yes, who is answering my question? Is this difference of two squares?
Yes, sir.
Okay, so how can I simplify? This can be written as 2x all raised to power 2 minus 3 squared. Is that correct?
Yes, sir.
So which means I can write it as 2x minus 3 times
2x plus 3. Yes.
2x plus 3. True or false?
True, sir.
Hello, true or false?
True.
Hello, please confirm you can hear me.
True.
You can hear you, sir. You can hear you.
Okay, very good. So you see what I'm talking about now. If once you are able to understand these simple things, like you are able to solve without wasting any time. So imagine that I ask you to resolve. I say resolve 4x squared minus 9 all over 2x plus 3 into partial fraction decomposition. I ask you to resolve this into PFD, right? So if you
Yes,
don't know the
sir.
difference of two squares, what will you do? You want to go back to the method I used in solving this method. You want to go back to this method because the first condition is met. The condition is that the degree of the numerator is greater than the degree of the denominator. And then you begin to solve using that method. Since I don't want your method, I don't want to see your steps, or I'm not going to see your steps. I'm only going to see your final answer, which is what they're going to choose as your option. And you're able to say, oh, this is actually difference of two squares. Just express it as difference of two squares. 2x squared minus 3 times 2x squared plus 3. And then divided by 2x squared. It's not no squared again. The squared would have been out. 2x plus minus 3 times 2x plus 3 divided by 2x plus 3. So 2x plus 3 will cancel 2x plus 3, and your answer will be left with 2x minus 3, which is going to be the answer. Just choose it from the option and you move on. You can even do this step in your head if you have become so good. You can do it in your head and you won't put pen on paper. You choose your answer, you move on. But if you don't know, you begin to solve by long division and then your time will be going. Please, am I communicating?
Yes, sir.
Yes, sir.
Very well.
Like,
Very well, sir.
like this,
Right.
sir.
So this is the type of questions you see in your exam, even though it has to do with partial fraction decomposition. But I will not be giving you what will take you all of this time to solve. But you need to know it actually, so that in case you see a particular question that is not difference of two squares, you know what to do. And when you see the one that is difference of two squares, you know how to handle it. Yes, Samuel, you're going to say something.
No.
It was Mr. Fortune. I was speaking there.
All right. I hope you are all good.
Yes. So what if you now say a question like that resolve
Are we
4x
all
raised to
good?
power 2 minus, let's say, 7.
Oh, the network is breaking. Come again, please. Sorry, come again, Samuel.
Yeah, I said, what if we see a question, something like this resolve 4x raised to power 2 minus 7. I think that one is not resolvable now.
No, that one is not difference of two squares. It means that you would have to use one of these methods I have just explained to solve it. But trust me, you will not find such question in exam.
Okay. Glory be to God.
Okay, sir. Thank you, sir.
Thank you, sir.
You're welcome. So yes, one more thing that I think I need to mention, which I would like you guys to review on, given what at least what we have covered the last office hour, we go a long way to help you in terms of polynomials, right? And what I have just mentioned on this call will also help you in terms of polynomials. So one other thing you have to think about is how to resolve partial fraction even without dividing. Let me give you another example. So what if you have something like this? This is another example here. This is my screen. Hello? Please confirm you can see my screen.
Yes, sir, we can.
So another example is if I ask you to resolve, let me say 2x squared plus 5x over, it could be resolve or simplify over, let me use over, let me say x squared minus 2x, something like this. When you see something like this, how can you handle this one? Because this one is, none of them is difference of two squares. Am I correct?
Yes, sir.
So since now the way to handle this one, since there is x, there are x's appearing with all the terms. So 2x squared has x, 5 has x. You can factor out x. Just bring out x. Here you'll be left with 2x plus 5 over. You can also factor out x here. You'll be left with 1 minus 2. Sorry, x minus 2. X minus 2. Am I communicating?
Yes, sir.
When you
Yes,
factor
sir.
out x like this can cancel this one. And then you are left with 2x plus 5 over x minus 2. Now, do you think there's any other decomposition that can be done here?
No, sir, unless we go through the long division.
Exactly. Beautiful. So because their degrees are equal. So if the question says resolve into partial fraction decomposition, when you get to this point, you don't stop here. You have to divide by long division. But if the question says simplify, you also look at the instructions. It's very important. If the question is simplify this, then this will be your final answer. There's no point to go further. If the question should say you should simplify, when you obtain this fraction, you stop. Don't go further. But if the question says resolve into partial fraction, when you obtain this simplified form, you have to divide by long division. And this long division will be very straightforward. Now, watch the long division. This is going to give us 2x inside, 2x plus 5, and outside we'll have x minus 2. When you divide 2x by x, the answer is 2. Multiply 2 by x, that is 2x. Multiply 2 by minus 2, that is minus 4. When you subtract, this is 0, and this will give us 9. And that's your answer. Your answer is now equal to, so you can see that there's nothing you can do again. It means 2x plus 5 has been resolved, minus 2 has been resolved to the quotient 2 plus the remainder 9 over the divisor x minus 5. Can you see that this one is also very straightforward? So in case you're told to resolve into partial fractions. So these are the partial fractions that has been resolved. We've been able to resolve this one. But first of all, I did factorization, I simplified the expression to this particular fraction. Then second of all, I did long division, which took just one step to arrive at the answer. So you would notice that if you see a question like this in your exam, it will take you only 3 to 4 minutes to solve. And then you are there. Am I communicating, please?
Yes, sir, you are.
Okay. So one last important thing I think I need to mention on this call. I don't know if that will capture Zainab's area of concern. Zainab said rational function, partial and field and other speed. Okay. I think we've captured this rational function. Let me talk about one topic that no one has mentioned, and it's an area of concentration. It is in binomial expansion. I hope you guys have seen the binomial expansion videos in the class.
I haven't seen it yet, though.
Binomial expansion. So this is also an area of concentration. Someone's hand is up. Victoria, your hand is up. Hi, Victoria, your hand is up. Can you go ahead and speak?
Oh, okay. I said the one I saw is binomial theorem, not expansion. Is it the same thing?
Yes. So the bigger topic is binomial theorem. So it's under binomial theorem that we do binomial expansion. But the focus is binomial expansion. Yes, it's an area of concentration in the exam.
Oh, okay.
Now, for the binomial expansion, let me just quickly show you the formula, right? The formula looks like this. So I'll tell you what's all about. It says if you have a binomial term, that is something like a plus b raised to power n, raised to some power. This can be expanded as the summation of n combination r times a raised to power a raised to power r and then b raised to power n minus r. Is that it? No, a raised to power n minus r, I think. A raised to power n minus r and b raised to power r, where r ranges from 0 to n. So this is the theorem, or this is the binomial expansion formula. So a simple example is
I'm
when you
sorry,
have
Elisa. I'm sorry for cutting you short. I didn't want to raise my hand. Can you please take this slide again? I don't understand all the grammars.
okay, I said for binomial expansion, when you have a binomial 10 x plus y, so this is a binomial. So when we say binomial, it means an expression with two terms, 2x plus 1. This is a binomial. Remember, we mentioned it when I was naming different polynomials. The day I was introducing polynomials. I said
Yes, yes,
polynomials
yes.
can be named by the degree of the power or by the number of terms. So when you have a binomial, that is a polynomial with two terms, and you want to expand it, if you want to expand it, like this type of expansion I did, okay, I think I cleaned it off when I was trying to explain this example here. When I was trying to explain this example, I think I expanded the 10 to show you that the degree of numerator is less than the degree of denominator. So when there's a formula for it, and the formula is what I have given. The formula is given by the summation of n combination r, x raised to power n minus r, y raised to power r, where r ranges from 0 to n. That is the formula for binomial expansion. To apply this formula, I'll give you a very, very simple example, and I'll tell you how to solve for the terms in a binomial expansion. Look at a simple example. If you are told to expand a plus b raised to power 2. So ordinarily, without using this formula, Zainab, this is very simple. Serious, just watch and see. When I explain this one, you see that it's very simple. Without using these formulas I have given here, ordinarily, what you would have done is this. You'd have said x plus a plus b times a plus b. Is that correct? This is expansion you'd have done, correct? Is that true?
Yes,
I
sir.
like reactions.
Yes, sir.
Okay. So and then you go further with the expansion. Multiply a times a. A times a is what? A squared. A times b is what? AB. Now multiply b times a. B times a is what? AB. And b times b is what? B squared. So you go ahead as a squared plus AB. AB plus AB is 2AB plus 2AB plus B squared. So this is the expansion for A plus B all raised to the power 2. That is by the normal expansion method. But if I want to use the binomial expansion formula, this is what I will get. A plus B raised to the power 2 equal to, by the formula, it says take the summation of 2 combination R, because here my n is 2, times a raised to the power 2 minus r, y raised to the power r, where r will start from 0 to 2 because my n is 2. So this summation sign means keep adding them. So I'll have the first term. I'll now be picking different r's where r start from 0. 2 combination 0, a raised to the power 2 minus 0 times y raised to the power 0, plus 2 combination 1, a raised to the power 2 minus 1 times y raised to the power 1, plus 2 combination 2, a raised to the power 2 minus 2 times y raised to the power 2. With this one, you begin to have your combinations. So 2 combination 0 is what? 1. 1 times a raised to the power 2, y raised to the power 0 is what? 1. 2 combination 1 is what? 2. times a raised power. Okay, why am I using y when the question is b? Sorry, let me change my y. This is supposed to be b, not y. This is b, this is b, this is b, this is b. So that is going to be 2 raised to power 1 times b plus 2 combination 2 is 1, 1 times a raised to power 0 and b raised to power 2. So finally we have a squared plus 2ab plus b squared. You can see that we arrive at the same answer. I can see some things going on in the chart. Let me quickly read the chart. This is, sir, it's simple because you're a mathematician. It's okay, you are mathematics itself. Okay, oh, Jesus Christ, it's hard though. I just commission. It is combination. No, don't tell me you've not heard of combination before. This my student.
I've not heard of
There are
it.
concepts called permutation and
I'm
combination,
just saying commission.
and it's in the classroom. You need to, yes. Someone is saying something.
So you need to change this your AOC. This expansion is too much.
The expansion is too much.
It's not true.
So that is it. These are the issues. Now the thing there is that you will not be required to do the whole expansions. Just understand my method, right? Even though there is a kind of way the question might look longer or the solution might look longer, you will not be required to do the expansion itself in the exam. So I'll give you a typical example of the way the question might come or would come. Now look at a typical example. I can ask you, what is
Sorry, sir, I can't hear you. Yes, sir, you are muted, sir.
I think it is network.
you see that some persons will begin to be scared and saying,
Sir,
this is going to be a
sir,
math extension.
sir, we have not been hearing you since for like a minute now.
Oh my God, that is network. Sorry
Yes,
about
sir.
that. So sorry, but let's see. Is it better now? Can you hear me now?
Yes, clear, sir.
Yes, sir.
All right. So, all right. Sorry, my other network had gone off. Like where I'm sure that you cannot see my screen now, right?
Yes, we can see your screen again.
I'm seeing the screen.
You can see
Which
maybe your
network?
network is lagging. Maybe her network is lagging because the screen had gone off from my end because of the my network is being interrupted. Okay. So while my network is trying to come up, let me just go ahead and mention and repeat what I said. I said the thing is that the expansion might look long, and you might even see a question that has a degree of 10 or a power of 10, a binomial expansion with the power of 10. But since the question doesn't ask you to actually obtain the entire expansion, but what the question is asking is to get the third 10 of the expansion. The question is asking for the the third term in the expansion. So it means that there is a technique, there's a way to actually go about that, getting the third term in the expansion without necessarily expanding the whole binomial expansion. Please give me a minute, please.
Okay, sir.
Okay, so I'm back. Zainab, you can go on with your question. I can see your hand is up.
Okay, thank you, sir. So I just want to confirm. The one you solved now, the a plus b raised to power in brackets raised to power of 2. Does that mean that whenever we are doing the summation, it should be like in the like 2 times like the raised power of 2 that we have there, and the one of 10 will also be in 10 places? Is that what it means?
Sorry, I lost you at some points, Zainab. If you can kindly come again. Sorry about that.
Okay, can you hear me now, sir?
Yes, I can hear you now.
I was saying the question you solved, yeah, the a
Yeah.
plus 2, a plus b in bracket raised to the power of 2.
Yes.
So you said something about the summation that is adding together like the total, like the number of times we have in the power. Is that what it means? Like, let's say we have a plus b raised to the power of 10. Does that mean we'll add that in 10 places?
Okay. Yeah. So if you have a plus b raised to power 10, okay, like this example I gave now. So you see, when it is power of 2, right? You can see we have how many terms? 3 terms. When you expanded 1, 2, 3. Can you see all 3 terms? 1, 2,
Yes,
3.
sir.
So when you are dealing with the expression with power of 10, the expansion will have 11 terms.
Oh,
It will be
okay.
so it will be so large.
Okay. I'm actually trying to like understand the whole solution, the first one. So this thing that look like Z that B3 is called summation.
That is a summation symbol. It's called
Okay,
submission. Submission.
okay, okay. And then we have 2 written on top and R equals 0 under it.
Yes.
So just because I don't understand this at all, to be honest. That and I'm trying to like get it on my own, but it just
Okay.
is hard somehow.
Okay. I see. So if I want to apply the same formula on this binomial term, it's going to be written as the summation of the summation of the combination of 10 combination R times 2x raised to the power of 10 minus R times y to the power of R, where R starts from 0 to 10. Zainab, did you see that? So
Yes, sir.
submission. Okay, I think I should first explain what submission is all about. So imagine I'm adding something like this. Watch it. If I'm adding something like this, x1 plus x2 plus x3 plus x4 plus x5. Instead of writing this whole x's, x1 to x5 in mathematics, we use the shorthand. It's called a short notation, shorthand. We write it as summation of xi, where I starts from 1 to 5. This is a short way of writing this same thing as above. Zainab, does that help?
Yes, 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 sir.
So that's a short way of writing what's above. Instead of saying x1 plus x2 plus x3, so I just say summation of xi, where I starts from 1 to 5. That means if you want to expand it, you will say x, because I start from 1, you will say
Yes.
x1, and the next number, and summation means plus x2, then plus x3. You will continue up to x5. You get? So
Okay.
going by this formula, it says that whenever you see a plus b to the power of n, you write it as summation of n combination r, even though r is not in the expression, but r is a term that is being used. So n combination r times the first term a, raised to power n minus r, plus or times the second term b raised to power r. And that is why I was able to apply the same formula here. My n is 10 here. So it's going to be summation of 10 combination r, where r starts from 0 to 10, right? Or 2x raised to power 10 minus r times r raised to power r. So it means if you want to now do the expansion for this one, you start where r is 0, where r is 1, where r is 2. So all of these terms here will appear in all the positions. So I'll start with 10 combination 0 times 2x raised to power 10 minus 0 times y raised to power 0 plus,
Sir.
then you do the one for where r is 1, 10 combination 1 times 2x raised to power 10 minus 1 times y raised to power 1 plus, you do continue until you get to 10 combination 10 plus 2x raised to power 10 minus 10 plus y raised to power 10.
Okay, sir, I have a question before we proceed.
Okay.
Okay, so is it possible to have the exponent as negative, like minus 10?
Yes, it's possible to have that exponent as negative 10. It's possible. So in that case, the expansion becomes different. And it's also possible to have the exponent to be fraction, like 1 over 2 or 3 over 5. In that case, the way you expand it becomes different. But all of those negative and fractional power, they are outside the context of this course. But not that it's not within what we should learn. But I refuse to bring it on board because I know that a lot of people will struggle to understand the positive power or the positive elements.
Thank you for not bringing it on board, sir.
It's okay, you're welcome. So let me quickly drive home my points before we end this call. Now, in normal sense, this is what you would have required to do to solve this problem here, this question. So you now, because the question says, what is the coefficient of the third term? So you have to expand it, then you start counting the terms. This is the first term here. Let me count it to the different color. So this is the first term here, 1. Everything here is the first term, 1. The second term, 2. Then the third term will be the one that has r equal to what? 2. So imagine the time it will take you to expand it and then simplify it before you get the third term. That will take you a lot of time. So, but since you know the formula, so that means everybody should know this formula. Very, very important. This formula. Know this formula and understand how to expand with the formula. And that's why I appreciate Zainab's question. She's trying to understand how she can expand with the formula. So once you know the formula and you know how to expand with the formula, what is then required is that you just go ahead and use the formula to obtain the third term. So what's wrong with my board? Receiving a response from the server, we recommend that you wait for 14 seconds. Okay, so you know that at the third term, right? At the third term, R is when R is equal to what? 2. When R equals 2 is where you have the third term. So which means that is that point you are just going to focus on. Focus your attention to when R is equal to 2. And I'll show you how to count it. Focus your attention to where R equals to 2. Yes, can you hear me?
Yes, sir. Please reload your board so that you.
Yeah, we can hear you, but we can't say the listen. You have to.
You have to reload.
Yeah, I'm doing that already.
Okay, sir.
This is my network. What is happening here? Please bear with my board. What is happening? Oh, network.
Sir, please bear with us to doing exam.
No, don't worry. I'm already bearing with every one of you. So don't be scared with these whole questions that we're solving here. When you see the exam, you yourself will be saying, Kai, you just be praying for me because the questions are so straightforward. Because
So
I
I
want
to just make all the questions polynomial. Polynomial is so sweet and simple.
Abby. Let me
Yes,
even
Okay,
so
now.
let
but
me
this
see
one
how many.
says polynomial. That is an expansion.
Polynomial is simple and so this by combination.
Say polynomial is simple.
Okay, so this binomial expansion, right? You will find, I think there are just 3 questions that are binomial expansion. Just 3 simple questions.
Thank God.
Yeah.
Thank God.
Then polynomial, you would see 1, 2, 3, 4, 5.
So
There are
you
about
forgot
5
to share
questions.
your screen.
Yeah, I'm even there with you. Please share.
Now, what about addition and subtraction?
2
Okay,
plus
addition and
2.
subtraction, you find a lot of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
So you are
10
not
of them.
sharing your screen.
Okay, wait, let me share my screen. Sorry.
What you are counting is what we want to see, sir.
This are serious they want to implicate me finally. You you want to implicate me finally. You don't know that this call is being recorded. Even if the call is recorded, say, I will not share my is that how is that how we do things?
It's Samuel and Zainab.
He says seeing
Samuel
is
and Zainab.
believing.
Wait, let me share my screen. My system is coming up. Let me share my screen right away because I don't want you guys to miss anything in what I'm saying. So please let me know once you can see my screen. Can you see my screen now? This is what I've been counting since.
Uh,
I hope you know the word. When you see the word quotient, you know what it means. When they
that's
say
funny.
what is the quotient? What is the quotient of 4 and 3? Do you know what it means? I mean 4 and 2, for instance.
The quotient is 1.
4 and 2.
Is it not 2?
It's 2. Quotient means division. 4 divided by 2.
It's 2 now. So if it's 9 and 3, it's 3 now.
Exactly. That is 9 divided by 3. That'll be 3. So those are the simple questions you find in your exam.
Okay, that one should
Sorry.
be like 50.
Sir,
That
you
would
are
be like
not
what?
telling us. You are not telling us the truth. We cannot see 4 divided by 2 in the exam. It's not possible. We will see
He said what
4x squared minus
the
3x
quotient of
minus
4 and 2
5y. That's what we will
using
see.
a more improved English. Is the
Okay.
fifth one.
That's what
Okay.
mathematics lecturers are. Okay?
Don't worry. It's after the exam, you guys will come back to give me testimony to say, sir, we really prayed for you. Let me quickly finish this thing. I know why I want to by all means conclude on this thing I'm saying because it's important. Let me quickly conclude on this. Can you see my screen now?
Yes, sir.
Yes, sir.
Good. So the question says, what is the coefficient of the third term, right, in the expansion? And the third term is you count when r equals 0, when 0, 1, 2, 3, 4. Oh, this marker. I say this marker, this board. I think I'll have to switch to PowerPoint since the board wants to begin to misbehave. I don't know what's wrong with the network. I guess the network is responsible for this.
It wants you
I'm
to
switching.
show us the questions.
I'm switching to, and it's important for me to mention it. So let me just switch to PowerPoint and get this sorted. But do anybody have the expansion? That is 2x plus y raised to power 10, right? Is it correct?
Yes, sir. Two exposure is one thing. Yes, that's correct.
Yes, sir, that's very good.
I'm switching to PowerPoint now. So please, can you see my screen?
It's
A
loading.
white blank page.
It's loading.
Okay. Determine the coefficient of the third term in the expansion of 2x plus y raised to power 10. Is it up now?
No, sir.
No, sir.
Wow.
Okay, it's up now.
Okay, good.
What is the law?
Has gone again. No.
Sorry, I'm busy battling with my network today. I'm really sorry about that, guys. Let's see. Um, so I'm sorry, please. I'm really sorry about all of this network
No problem, sir.
issues.
Problem, sir.
Uh, oh my God, this network don't want to.
Yes,
Let's
sir.
see.
Can you help us solve it the way you did that YouTube video?
Okay.
Okay, I should solve and upload, right, and share. Okay, I think that makes sense.
Olawale, sir, I'm not. I don't think that will work for this by binomial combination
The
because
network
Hmm.
is network.
okay, maybe you can. So we'll come back to see if you have further
Yes,
questions.
you still come back to him. We
Okay,
still do
okay.
another section again.
All right. I will do that, and I think I will even solve like 2 or 3 examples to buttress my point, and I think that will be helpful. So I'll do
Thank
that
you
and
very much.
share. I'll do that and share before 2 3 today. Hopefully my
Okay.
network becomes stable for me to upload to YouTube. All right. So I think this is a good place for us to draw the curtain because of these network issues. But like I said, I promise to complete that question because it's very important, very very important that everybody knows how to solve questions like that. Okay.
I will still come back next week.
Sure. All right. No
Yeah.
problem. No problem. That's fine.
I don't know, sir. I have a question, sir.
Okay, please go ahead.
I don't know if it's possible for us to extend the time from 1 hour 30 minutes to like 2 hours close because we've not been able to like touch a lot of topics, and this is week 9 or 10 already.
Right. So do you mean in this our special office hours or during the live
Yes.
session?
No,
Okay, this
live
special office
session.
hours.
Yes, sir.
Okay, no problem. We would. I will consider that. That is fine.
Okay, and then sir, can it also to buttress what Zenob said? Can it be more like the day should be more specific? So let's know because I think last week we did it on Thursday. I think let it be if it is every Thursday, let it be stated. If it is every Friday, let it be stated. I don't know if I'm clear.
Mr. Samuel, because of this is an office hour. That is
Yeah.
why we are just taking any day because
Okay.
of everybody. Everybody might not be free.
Okay.
and then the lecturer too.
Today one was very impromptu. I just saw the call around 11.
No.
Oh,
I've said it like Wednesday or Tuesday or
okay.
so.
Okay. Thank you. And then, sir, please don't forget to upload the one we did last week
The
also.
other one. All right, sure. I will do all those hopefully before the end of today.
Thank you,
Thank
sir.
you very much, sir.
You're welcome.
Easy or not,
Thank
sir?
you, sir.
All right. You're all welcome. Do have a wonderful day ahead. And I wish you all the best as you prepare for your forthcoming exams.
Thank
Thank
you
you,
very
sir.
much. Have a nice
All right, and you too. Bye.
Bye.